Swayam Prabha. Digital India. Educated India.
Good morning everybody, and let us continue our discussion on the linear motion or linear guide way that we have started in the last class. In the last class we have seen that linear guides way are more important or more suitable for the micro machining operation compared to box way type, because they have less contact point. So, if the contact point is less, then your friction will be very less and you can easily move in a frequent axis travels in the opposite directions also. So, let us continue that video which was we started in the last class. So, in the last class we have seen different type of definitions: service, rated service life, dynamic capacity and all these things, and these are the two terms which are very important in terms in the bearing application. One is the preload and another is the backlash. So, let us see that how these things are playing important role in the bearing or the linear guide way design. So, now consider this is the one thing. So, now what is happening here? So, this is a thin person and he is sitting in a car, but now if you see here, he is not actually fitting completely in this, there is some space available. So, this is the space available, this is the space available and this is the space available at this location, correct. So, now what is going, when you are riding this car and when you stop it suddenly, what is going to happen? This particular person will move in to and fro direction. So, it does not have any type of motion constraint, right. So, see now it is moving in this particular both the direction. So, it has some type of clearance, and so there is a backlash, but no preload. So, the preloading I will also again explain. So, this is what is happening in this case. Now, consider the same car, but you are actually forcing one fat person or the big guy into the car. So, now you can see that there is no space available, nothing is available here. So, everything is completely packed. So, when this car is moving and then suddenly it will stop, this particular person will not get any type of motion in any direction. Correct. So, there is a preload and no backlash. So, this is called the preloading of that part. So, that is also required in this particular case, because what is going to happen here? So, this is the situation where the small bearing diameter and this is the length where we have to keep our diameter. So, now this is the thing that this is the rail, correct, and diameter is here. So, this is the particular backlash, right. So, if that backlash is present, what is going to happen here? Let us see. So, this is the motion of that part, because now you do not have firm contact between the ball and the roller or that rail, and because of that you are getting some type of wavy motion instead of a straight line motion. So, now it is exactly fitting here. So, you do not have any type of contact. So, this is exactly matching with this part. So, no any type of clearance between the rail and the ball. Correct. So, if you consider this particular motion, then this is the bottom part, you can see that there is no backlash and motion is more precise. So, why this thing matters? Because whatever we are looking at this particular location, so those things are not exactly the whatever way it is moving up and down, it is highly exaggerated view, but if you see it in a micro level, then that is also enough to destroy our workpiece geometry. Because now if you want to cut something like this straight line, this is your workpiece and you want to cut something, one slot here in this case, if it has a backlash here, then what you are cutting actually. So, this is the thing and you are cutting something like this, right. You will not get a flat bottom surface at machining surface, because you are considering that your workpiece is moving in a wavy direction, and because of that you are not getting a precise movement of the cutting tool also. So, that is what is going to happen because of this backlash error. Now, what is the rigidity? Rigidity is mostly we can define the deformation under the force. How much force you are defining, or how much is the deformation it is happening. So, let us take this example that you have a very lightweight, that means bus, nobody is sitting and one person is coming suddenly with some velocity and he is jumping in on the bus. So, now what is going to happen, that bus will actually displace here, that means it will give some type of motion, and that motion is called the problematic things. So, that is called raw rigidity, because when you are forcing something onto the component and if the component is not resisting that particular force, then it is called the raw rigidity. So, this is what is happening here. Now, consider that it is a bus is completely full, and that means it has a little bit high rigidity, it is not deflecting or deforming under the application of external load. So, now the same person is coming with a speed, now you can see that it is not moving too much compared to the earlier case. So, now this is the way we can define the rigidity. So, when you define rigidity, higher rigidity means less deformation or it will resist more deformation. So, this spring is not compressed more, so it has a high rigidity, and this one has a low rigidity because it has compressed little bit more. So, why this thing is important? Because these things are important when you are machining at a cutting tool, because when the cutting tool cut in contact with the workpiece tool, at that time there are forces occurs. So, you consider those forces something like this. If your guideways and other elements which are not able to resist that forces and they deform, that means your machine has a low rigidity. If they do not deform, but it will act against this type of external forces, then we can consider it as a high rigidity. So, now this is considered the backlash. Now, under the backlash, what is going to happen, that when you add a 1 kg load, now we have backlash, so your whole thing will go down, and once you go, it will go down. What is happening here, that this is your reference surface and now your reference surface is shifted to little bit down. So, now your whole machining is going wrong way because of this thing, because now consider that again the same example, that you want to cut something one slot, and this particular depth you consider it is a 50 micron, and because of this problem what is going to happen, that your tool will, your workpiece will go down. So, now consider your tool initial position is this one, this is the initial position, and you have given 50 micron of depth into the tool, but because when you are doing this particular thing, this is your machine, or this is your part program by which you have programmed this particular tool motion. But if that is the case, what is going to happen, that because of this backlash, your workpiece is whole thing is shifted, this is the base surface, right. So, this is the 0 position, and when you are going to do this thing, at that time there is a deflection going down little bit. So, consider that deflection is 10 micron. So, this is the minus 10 micron down. So, what is going to happen, that your tool is still here and you assume that your tool has gone into the 50 micron from the workpiece top surface, correct, but your top surface is shifted here down. So, this is your actual things which you want to cut, but what is going to happen, because of this particular deflection, what you are cutting is this one, right. So, you are getting a dimension difference of a 10 micron. So, your depth of cut you require 50 micron. So, this is required, but what you are getting a 40 micron, correct. So, 10 micron is moved down because of this particular backlash. So, even it is very difficult to get this thing realized during machining also, but ultimately when you complete the machining and measure the dimension, then only you will find that there is a error. So, it is better to avoid the backlash. right. So, this is the deformation, your reference line is shifted and it has poor rigidity. So, when it is a no backlash, at that time what is going to happen, that your reference line will not shift there, and all the things whatever loading is there, that will be taken care by the parts. So, how do you manufacture this particular linear guides way? So, first thing is the rail creation, and what matters here maximum part is the straightness, because if you consider that we know that we want to move something in a straight line, correct. So, this is what is our required line, but if your guide when you are manufacturing it, it has some type of problem in this direction, let it be in few micron only, but it will create a lot of problems. So, straightness is more important. We will see that there are many different steps or the processing steps are performed, which are only to make sure that there is a straightness between the layers. So, heat treatment is required because now you do not want these particular things to deform during the operation, let it be static deformation or the dynamic deformation. So, these are the straightening, first straightening, because initially you have to straighten it and then you have to do drilling, because we have to mount many things here. Then straightening process 2, after each and every operation you have to again perform the straightening operation. Then after straightening you have to create a reference surface here. Now, what does it mean? Now, consider that you have one block with a very odd shape. Now, this is the surface. Now, what you want to do, that you want, your objective is to create a perfectly rectangle out of this. So, what we generally do, that first you do machining operation and remove this layer, and then you do grinding operation. Once grinding operation is over, then what you have to do, that you have to mount this thing upside down, correct. So, now we have created this reference surface. So, all the dimension whatever you want to machine, suppose it is a 10 millimeter, then 10 millimeter count will be done from that location. So, now this is your reference surface. So, you have reached to this location. Now, mount in upside down. So, now your surface is something like this. Let it be again the very uneven on the top surface, but your bottom surface is completely flat, because you have taken as a reference surface. Now, what we have to do now, that now you apply that 10 millimeter. So, now you measure that from here to here how much is the 10 millimeter, again do the one machining operation and one grinding operation, so that you can get the 10 millimeter. So, when your surface is not when your surface does not have any type of shape, then at that time you have to create one reference surface, and from that reference surface then you continue all the operation with reference to this part. So, that is it is called the reference surface. So, your calculation of all the dimensions, let it be depth also or the width also or the length, everything will be taken care by this particular surface reference. So, that is it is required for this operation also. Right. So, this is the processing of the rail, and same thing we have to do for the block also, because we have to mount one block also on the top, then again the drilling and all the operations are same, and again you have to create the reference surface, because both things are in the matching part. Because earlier what we have discussed, it is for the single component, but if you have a two component which are coming into contact with each other, then you have to create a reference surface for the other one also. After that operation you have to grind the bearing groove also, because you have to make sure there is no any type of dimensional problems. Tolerances should be as tight as possible, so that you will avoid any problem at the later stage. Then finally assembly, once you cut everything okay, then this is the assembly of the process. So, you are putting all the things, guides and everything, ball also together, and then mount everything from this side. So, this is the final part. So, these are the different about all the things. Now, where you are using this thing, we are using it wherever we need a very highly precise motion. Mostly it is for pick and place type of thing, moving one component to other location, where few microns of difference also play important role. So, those are the application of the process or this particular linear guideway. So, let me finish this video now here, and we continue with the lecture. correct. So, we have seen all the things that these are the different components and how this is better than the other kind of things. Linear guideway, after that there is called hydrostatic guideway. So, what is this hydrostatic guideway? So, what is happening here? In earlier case we have seen that this is the moving component, we are putting balls here or we are putting rollers here, correct. So, that is to reduce the contact point between the two surfaces when they are in motion. So, now consider that we have situation. So, this is the one thing where there is a full surface contact. This is the another thing which we have seen recently, these are the balls, okay. And this is the third one. Okay. And what is happening here, that some liquid is coming from this and then it is creating one film. So, this is called liquid film. Now, consider all these three situations. In this one, very large contact is there, the friction is very large, correct. Second one, what we have done, we have reduced the contact. So, now our contacts are at the either it is a point contact or it is a line contact depending on the use of ball or the roller, but still they have contact, right. So, friction is little bit less. But now, if you avoid this thing completely, that there is no any type of mechanical component in between the two surfaces. So, what we are adding here, that we are adding a liquid film here, we are pressurizing in such a way that whole thing will be lifted. Now, consider this is the hydrostatic pressure and this is the load. So, it always balance this particular thing, that when you are adding the load more, your hydrostatic pressure will increase. So, every time this will be in the stable condition. So, in this case now what is the advantage, that we are not getting any type of mechanical component between the two surfaces. So, that is very good advantage, that now friction is completely avoided. Only thing will matter different is the what is the viscosity of this particular liquid which we are using here. So, it is more convenient or more useful than this particular case, that is a full contact or it is a roller or the ball contact. So, that is called hydrostatic guideway, because hydro that means we are using some liquid, static means we are continuously providing. So, it is in static loading, not in a dynamic. So, there is another thing is hydrodynamic guideway, where when you rotate a particular component, that is called rotor, at that time it will create the film depending on the rotation of that, but that is in dynamic condition, but we are looking right now here is the hydrostatic guideway. So, it utilizes a pressurized liquid film about 15 micron to keep the bearing afloat. Bearing afloat, that means this is the part and not in contact with the lower channel. So, this lower channel is this one, this is the lower channel. So, this particular fluid, whatever we are using, oil or any other type of liquid, then it always makes sure that there is no direct or physical contact between the two surfaces. One is the stationary channel and another is the things which is moving up and down. So, this is the one of the a schematic diagram of that thing, that how you have to provide this particular part. So, now you can see that this is the oil supply, whatever from where you are supplying the oil, and that oil is actually equally spaced or distributed in between the two surfaces which are in contact. So, this is the lower one and this is what it is moving on the top. So, this is the top one, right. So, this way you can actually increase the comfortability, or what we can say that reduce the friction between the two contact points, and then you can easily move freely without any type of more friction. So, let me show you this video also here. Right. So, this is the hydrostatic part. Now, you can see just by putting one finger you can actually moving this whole things, because it weight may be 5 to 10 kg also, but you can see that just by finger you can move because now we know that there is no any physical contact between the two surfaces, or whatever liquid is present here, this particular liquid is creating a film between the two surfaces, and you can easily get the low friction part. Now, this is the thing which is mounted on the part. Now, you can see even it is loaded with a very heavy component, still the same motion you can get by this particular frictionless hydrostatic bearing. Correct? Right. So, what are the advantages? It has ability to handle very heavy loads without generating friction fluid that are contacting slide wood in car. So, in these particulars it will, because now we are using a liquid here. So, it load carrying capacity is very high in this case, but what is going to happen that we know that in micro machining we are not working with a very heavy loads here. So, it may be used for some of the application, but exactly we are not getting this particular application in the micro machining also. So, what are the advantages of this hydrostatic guideway? Though it has a zero static friction, and advantage of zero static, we know that we are not getting any type of resistance because of the motion. A dynamic friction depends on the gap and the fluid viscosity, because we know that if the fluid viscosity is very high, then you are getting more friction, but still that friction is much less than the physical, that is mechanical contact type of surfaces. Then very intolerant to the dirt. Now, that is very serious thing here, because we are using liquid here, and we know that this particular gap is 15 micron or so, something like that. So, if you are dirt, you are not filtering this liquid very perfectly, then what is going to happen? This dirt will create some type of problem here. It may clog this particular passage, and then you have to find some way to remove those things. So, filtering of this particular oil, whatever oil or other liquid you are using, that should be perfectly fine without any type of impurities. Right. So, fluid has to pass through a tiny gap, a capillary or a orifice, it can clog. So, that is what is happening here in this case. A particle lodged in the surface small gap can score the bearing or the rail. Now, there is another problem, because by chance if the particle size is smaller than the 15 micron, consider that is the thing. So, first thing that it will not clag, right. So, particle smaller than 15 micron, right. So, if this is the case, then no clogging, correct. But what is happening here, that if it is a small particle, now consider these are the small particles, and we know that this whole thing is a closed loop circuit. So, this particle may again come into contact with this type, and then it will actually contact these particular surfaces. So, when you consider that this is the surface and one particle or more than one particles are contacting this particular surface, and they are rubbing with this part. So, not in a short duration, but after a long period of usage, what is going to happen? This particular surface may create some type of deformation or some type of removal or the abrasion wear, and because of that there is a scoring of the rail, and once the scoring of the rail is there, then the gap maintenance is very difficult, because now you have uneven surfaces, and whatever calculation you have done with respect to load, with respect to the hydraulic pressure, how to maintain this both the things, that calculation is now not applying here, because your surface is now different than the earlier design surface. So, this is the problem. So, your filtering process should be very strictly monitored, otherwise there will create some problem at the particular stage. Right. Now, coming to the aerostatic guideway. So, what is the aerostatic guideway? So, only difference between the hydrostatic guideway and aerostatic guideway is that you are using air in place of liquid, right. So, this is the same thing. Now, consider this is the shaft and this is the bearing, and this is the same base. So, here what you are putting a air. Earlier case in the hydrostatic, what we are using? Liquid, and in a aerostatic we are using air or gas, right. So, this is the difference, but now there are many other advantages also for hydrostatic guideway. So, before that let us see this video that we can get more information by animation that how these things are important. So, what is this thing that here what we are doing that this is a table and on the top of this is the slide. So, you consider x or y or it is mounted in vertical side, then it is a z axis, right. So, we need a frictionless this particular part. So, how this thing will work here? So, where we are mounting our air bearing, we have to mount our air bearings here, and this is the air supply through which you have to supply the air from this part. Right. So, it is moving in this way. So, now let us go more into detail of this part. So, this is the bushing and from here what we are providing? We are providing air in this particular interface. So, now this is the interface. So, this is the shaft and this is the bearing and in between this is the fluid film. This is called air film and that is the same way in this direction also, correct, because we have to keep this shaft in the central position of this particular part. So, air is supplying from this part also, this is also and this way also. So, air is coming continuously in this particular ways, correct, and these are the opening, that means exhaust of the air will pass through this, it will go away and here it will go from this direction, again this is the passage, so it will go from this way. So, it is now in environment, so you do not need to worry about what is going to happen after release of the air, correct. So, now what is going to happen that now it is in a free motion. After that what we are doing that we are adding workpiece, we are adding the tool and doing machining and everything. So, your displacement, this whole thing will go down. Because of that what is happened that earlier it was balanced force, right, force at this location and this location both were same, but when you are putting this thing down what is going to happen that this space is available here is less. If the space is less your pressure is more and here space is less, so your space is more, so your pressure is less. So, after once this thing happens at that time what is this particular bearing will adjust itself, you do not need to see that how it is going to happen. Right. So, after in this location this is a red color, that means high pressure, again this both things are maintained, now both things are in blue color. Again it will go down, this becomes less high pressure, this is a low pressure zone, again it will match the part. So, in this way what is happening, this is a self adjustment bearing. So, wherever there is a pressure difference it will maintain that pressure difference by pressure regulator of this particular air bearing. So, this is way how it is useful. And once there is a no contact of this part, then you can easily actually move this shaft to and fro or you can move the table to and fro, that is up to your application which one you want to make it stationary, which one is a movable component, correct. So, this is the from the side view. So, now this is the way you can actually measure. So, your shaft is always at the center irrespective of the loading. So, only thing you have to make sure the loading is within the permissible limit of the pressure of this particular ball aerostatic bearing. Correct. So, it is a highest resolution great machine constitution due to 0 wear. So, compared to that hydrostatic, what is going to hydrostatic thing, there are the hydrostatic pressure was creating a problem because the viscosity what we are using fluid viscosity, if the high viscosity fluid is used then there is a problem in this particular case. So, you are getting a little bit more freedom in terms of the wear of the component and the friction, correct. So, a non-contact system where a gas film typically mostly we are using air act as a lubricant that separate the two surface in the relative motion. So, this is what is happening in this particular case. So, now we have seen that we have a different kind of bearing. One is the bush bearing where there is a surface contact, then there is a ball bearing, and then hydrostatic bearing, and then there is a aerostatic bearing. And we have all things, we have a separate application, because we cannot say that this is the best one, it can be used for everything, but there are different ways by which you can find out a specific application where these are applicable, because this is not universal, that one is also not universal. Every application has some limitation. So, you have to find which particular bearing or which particular guideways are more important or suitable for your application. So, let me finish this class here. We will continue this guideway topic further in the next class. Thank you very much.